This example is finding the cumulative area function a of x from 0 to x f of t dt, integral of from 0 to x f of t dt, and we want to express a of x as a piecewise defined function. Over here, I'm observing the function that I'm trying to find trying to integrate is this function from 0 to 2. It's this line. And what line is that? The slope of the line is 1, and it goes through point 0 and -1. So this piece is y equal to x minus 1. And this piece is y equal to 1. So I can rewrite the function, and that's the f of x, as x minus 1 for x between 0 and 2, and then 1 for x bigger than 2. Now that we rewrote the function, we want to take the integral of it. So one thing to consider when we're taking the indefinite integral, where it's the cumulative value. So we're finding the net area always from 0 all the way to the x value that we're finding. Here, if I have x value, for example, between 0 and 1, it would be a negative value, negative of that area. If I have x value somewhere between 1 and 2, it would be negative of this value plus that value. And then as I move on, if I have x over here, I have to add or subtract this area, add this area, add that area also. So let's start going about this. First of all, since I have f of t, I kind of prefer to change x to t. So now we're finding a of x, and a of x is integral from 0 to x of the function from the function when x is between 0 and 2. So writing that up, that would be t minus 1 dt, because the f of t between 0 and 2 is t minus 1, and this is x between 0 and 2. The next part is to find the area when x is bigger than 2. That would break the function into two pieces. One is from 0 to 2. The next is from 2 to x, because the rule of the function, of the piecewise defined function, is different from 0 to 2 than it is from 2 to x, if x is bigger than 2. So I broke down 0 to x into two pieces because I wanted to apply the two different rules of the function inside. Now let's calculate. So a of x is equal to, well, I need to find the integral of t minus 1 in this corner on my scratch paper. T squared divided by 2 minus t plus c. Plugging in the values, when I plug in x in there, I get x squared divided by 2 minus x. If I plug in 0, I get 0. And notice that I'm not considering c because this is a definite integral. Now, integral from 0 to 2 of t minus 1 dt, if I plug in 0 and 2 in here, if I plug in 2, it's 2 to the power 2 divided by 2, which is 2 minus 2, 0. If I plug in 0, it's 0. So this part is actually 0. Now, what is remaining is to find this antiderivative. Antiderivative of 1 dt is just t plus c. Plugging in the value, I get x minus 2 for x bigger than equal to 2. And if you notice, at x equal to 2, what we get is 4 divided by 2 minus 2, which is 0. And here we get 2 minus 2, which is 0. So this is still continuous. And this is our answer.